Okay, we're going to continue on volume today. We're going to get the volume of composite shapes. Remember what a composite shape is? We talked about it a few videos ago. It's a shape that's composed of two or more geometric shapes kind of stuck together, right? So this is a composite shape because it looks like one rectangular prism attached to another rectangular prism. So how do we find the volume of something like that? There's not really one formula for this shape, but what we're going to do is we're going to find the volume of the individual shapes and then just add them together. It's not too bad. When we do surface area, it's a lot harder to get the surface area of composite shapes, but volume's not too bad. So here you go. You're going to find the volume of this shape right here. So we got to break this into different shapes that we actually know the volume of, that we actually know the formula for. So you have some choices here. You actually, I think, have three choices. One choice you have is to break it across here, right? Then you'd have one shape up here, looks kind of like a cube. I don't think it is, but it looks like a cube a little bit. And you have a rectangular prism down here, and you add them together. That's a choice we could do. Another thing you could do is you could split it here. Then you have one rectangular prism here, and another rectangular prism there. And the third choice you have, which many people forget about, but is a possibility, is you could complete the rectangular prism here. Make one giant rectangular prism. Right? So then you could get the rectangular, the volume of the whole rectangular prism, and then get the volume of this piece here that I've added on, and you could subtract. So those are three different ways that you could actually do this. Which way will we do? I don't know. I don't know which one you guys want to do. How about this? I'll go with this one right here. I'm going to cut it right there. So we have this shape here, which I'm going to call A, and we have this shape here, which we're going to call B. And in order to get the total volume, what I have to do is add together A and B. I'm actually going to start with B. I think it's a little bit easier. So to get the volume of B, how do I do that? Well, this is a rectangular prism, and the volume of a rectangular prism is length times width times height. In this case, what do we got? We've got 2 here. We've got 3 here, so this one, and then we need this length right here, don't we? How much is that? Well, if you look, that length right there is exactly the same as this length here. It is exactly 8 millimeters. So all we have to do for this piece is to multiply the 2 times the 3 times the 8. And if you do that, 2 times 3 is 6 times 8 is 48. 48 what? Well, we're talking about volume, so it's going to be cubed. So it's 48 millimeters cubed. Alright, great. Let's get rid of these lines. And I'll leave the blue one because now we want to find what the volume is of A. So to get the volume of A, it is again a rectangular prism. So we have to go length times width times height again. So what are the dimensions we need here? We need this dimension here. We need this dimension here. Actually, maybe I'll do it a different color. We need this dimension here, and we need this dimension here. Well, one of them is very easy. It's the purple one. It says right there that it's 10. So you'll notice I don't really care which one is length and width and height. All I care about is I need those 3 dimensions. So I'm going to put the 10 right here, even if it's not the length. I don't really care. Alright, what's the next one? The next easiest one is probably the yellow one here. Because look, this yellow is exactly the same as this. It's exactly the same as this, and any of the ones that are parallel are exactly the same. It's exactly the same as this, and it's exactly the same as this. Oh, so the yellow one, way back up here, is exactly the same as this. It's 2. So I will put times 2 here. And then we need this green one right here. How are we going to do that? If I look at the ones that are parallel, I don't know any of those. Alright, here's the thing about that. From here, all the way over to here is how much? It's 12, right? From here to here is 12. Now, how much is it from here to here? That is 8. So the question is, if it's 12 from here all the way to here, and it's 8 from here to here, then how far is it from here to here? Well, the 8 plus something has to equal the 12, so this amount right here must be 4. That way we have our 4 plus another 8. It gives us our 12 total. Alright, so we are going to also multiply by the 4. 10 times 2 is 20, times 4 is 80 millimeters cubed. So if we want to get the total volume all we have to do is add those two numbers together. 48 plus 80, we get 128 millimeters cubed. Okay? If we'd done it one of the other two ways I mentioned, we would have gotten the same answer. I'm not going to spend the time to do that though. Alright, the only other question I'm going to do is this one. It's another composite shape. We obviously have, looks like a cube, but it's not. If you look, all these sides are different lengths, and we have a cylinder on top. So there's no cutting or anything necessary here. All we have to do is get the volume of this, add them together, we're done. If this was a surface area question, it's a very challenging question. But as a volume, it's not that bad. So let's do this. Let's get the volume of A to start with, because it's easier again. This is a rectangular prism, even though it looks like a cube. So length times width times height. So what are the dimensions we need? We need this dimension, we need this dimension, and we need this dimension. This last dimension I drew is exactly the same as the 18 there, right? It's exactly the same amount. So basically we're multiplying 20, 16, and 18. So it equals 20 times 16 times 18. Probably need a calculator for that one. And we get 5,760. This time we're talking about meters. Whoa, this thing's huge. It's meters cubed. Okay, now for B. I mean, it's not really that much more difficult. It's just that the formula for the volume of a cylinder is a little more difficult. Remember what it is? Get the area of the base. Well, the base of a cylinder is a circle, and that's pi r squared. And then multiply it by the height. So you get pi r squared h. So I'll keep the pi for now. Radius, be careful. The radius is not 6. 6 is the whole way across. So halfway is just 3. So we got to go 3 squared, and the height of this thing is 10. So if we go 3 squared, you get 9 times 10 is 90. 90 pi, basically. So if you wanted to get the whole thing and you want it to be absolutely exact, the total volume is 5,760 plus 90 pi. Now that's more a grade 10, 11, 12 answer. What we usually do in grade 8 is we actually figure out approximately, I mean we can get very, very, very close, but we actually figure out approximately what 90 pi is equal to. But if you wanted an exact answer, this is the only way you could write it. How come? Because pi is a decimal that goes on and on and on forever. So what I'll do is I'll keep the 5,760 and I'll multiply 90 times, and I'll use the pi button on my calculator. That'll give me my most accurate answer possible. So 90 times pi is equal to 282, and I'll do 2 decimal places, 74. And now I could add on the 5,760, and I get my final answer, which is 6,042.74. And what were we talking about? It was meters, right? Meters cubed. I guess I could also write meters cubed right here. Okay, and if you're doing your exact answer, it would be this many meters cubed. So here is our answer there. Alright, there you go people. That's how you do composite shapes. Just break them up if necessary and find the volume of each different shape and add them together. Take care, and we'll see you next time.